comes into picture. And coming from a downstream EO sector, like we understand the challenges and issues in processing multiple sets of data. So be it aerial, be it like from the satellite Earth observation data, and also we have worked with data sets from drones, right? And combining these data sets together and deriving information, which is what the topic of this panel is, right? And that is something which we have realized the challenges, I think, sometime in 21, 22. And over the last 1 year, we have built a data processing pipeline where we are looking to ingest data from multiple data sets, like drones plus aerial and plus satellite Earth observation. I would say we are very early stage in combining data with SAR as well, which Suyash has talked about. And yes, like he mentioned, it is challenging, and that is something which we are also looking to work with. And yeah, like just to put things in perspective, wanted to talk about how data sets from different sources can be combined together, and what are the challenges and how it leads to say efficient decision making at different levels of an organization, be it military or even civilian organizations, right? The recent conflicts that are going on across the world due to proliferation of civilian Earth observation data, anyone can go ahead and order data which is slightly lower resolution, or in case like even higher resolution of around 1 meter or less than 1 meter, you can go ahead and order, which is expensive, and do your own analysis, and which is what many of the military bloggers have been doing since last 1.5, 2 years, and we have seen combining such civilian analysis data sets into institutional data analytics. Basically, it is meshing of civilian data sets into strategic data sets and having to take decisions. In fact, I think it was one of the countries who used NASA's Landsat plus MODIS data set, which are very low resolution. Landsat is of 30 meters GST, and MODIS satellite is something of around 200 meters, if I remember correctly, which is a part of their forest information resource management system. They have tried to use that civilian data set to understand where the artillery usage is happening across their territory or across the enemy's territory. So as the civilian satellite operators start operating, there is inadvertently, definitely there is, we will be venturing into a space of strategic use cases as well. And these satellites can definitely help in making or building solutions for strategic use cases. And as a processing company, yes, like we go down to starting from, say, data capture, processing the data chain, and bringing out analytics so that decision makers can take their decisions efficiently. So, yeah, thank you.
Now let us hear from Mr. Kannan Keshav, co-founder and CEO of Allsense Labs, to brief his views.
Thank you, Chair. Hello, thanks for SIA for giving this opportunity to introduce myself and my organization. I'm Kannan, co-founder of Allsense Lab. Probably we are one of the very early stage startup here. Allsense Lab started with a philosophy of any sensor output is just a tip of the iceberg. We can still squeeze out 90% of untapped information using computational sensing. So we started as a computational sensing startup. We were taking expertise people from medical imaging, etc., how to build our sensing solution. When it comes to machine intelligence, Suyash and the chair talked about multi-sensor payload, we were considering going one level down. As Lieutenant General Panu mentioned in the inaugural session, we are seeing an overload of need of sensors and need of more sensing data. So we started our journey of building an RF sensor which can act as multiple modality. Can a single RF sensor can meet the sensing need for surveillance, atmospheric profiling, pollution monitoring, etc. So in this way, if we are able to achieve that, we will be able to reduce the need of different missions. Say for example, radio occultation missions and RF missions can be combined. So you can have multiple missions at the same cost. And second problem which we consider is when it comes to surveillance, relying on active radar. During a peacetime, everything will work. But during a wartime, you cannot have active radars surveilling on an enemy territory. It will give a reason for anti-satellite technologies to kill our satellites, kill our HAPs or drones, etc. So we decided that we wanted to create a sensor can collect more data passively. Can a passive reception of RF which lead to passive SAR, which lead to radiometer, etc., which can be giving data, same time data to the defense and to the industry also. But in this particular context, one of the limiting factor where we were struggling is how to capture the weaker signal, because your algorithms, you can come up with innovative algorithms, but to work with innovative algorithms, you need to capture weaker signal. So we in Absence Lab, what we are trying to do right now is, we are building a quantum enhanced RF receiver, which can scale at multiple levels, drones to HAPs to satellite, and which can sense weaker signals. So we believe that once our sensor is completed, we will be able to create modalities which we have not even thought about it, or which we can collect passively the intelligence, same time give atmospheric profiling information to the industry and do a usage. So to create, so this is one of the opportunity we are working on that. To sustain this, we might need to not only ask any satellite, we are playing only in the sensor level, we are not a satellite company as such. Should be able to create satellite solution which will same time cater the need of the defense and to the industry. So probably one of the challenge with the existing satellite companies and the defense is how to exchange the data. Probably this is one of the area where the defense think tanks also need to work on it. How the exchange of the data from a defense satellite to industry has to work. We should have an agreement of level 0 data can be given only to the defense, but level 1, 2, 3 data can be given to public. So if we create that kind of a mechanism, then we will have the economical advantage to create more satellites, more HAPs, more drones, and same time we can limit our cost. This is our initial thought. We can catch up anything, any specific point. Thank you.
May I request Mr. Gurvinder Chauhan to share his thoughts?
Good morning. My name is Gurvinder, and I've been listening to since morning this conversation, what's going on, and discussion, and a couple of points are very intriguing where we are heading. And I heard all the comments made by all my colleagues here. What we are talking here is so far downstream. What I'm going to talk about specifically focus only on defense spectrum. What we do, defense, theater, warfare center. Unfortunately, I had a very nice slides to show exactly what we are doing, but organizer decided not to show any. And sometimes one slide is worth 1,000 of words. But I try to give you a visualization what we are doing. So QST is about a 10-year-old company, and the name stands for Quantum Scientific Technology. So originally when we started, the whole idea was to come up with a quantum-based technology to fusion and develop some new technologies to replace RF technology, optical technologies, and laser communication systems. Then we gradually grew, and now in some short span of the last 4 or 5 years, we are proud to say that we are the first company in the world to have a smallest geo satellite in orbit. It's only 16U and it can provide you multi-platforms in which we have SDA, 2 telescopes, 2 cameras, 14 megapixel and 5 megapixel cameras, and you can take pictures of any asset in orbit. Number one. Number two, you have a RF sniffer. So you do sniffing and look at what's going on, RF spectrum monitoring. Number three, you have a communication payload, all in 160U and 40 kilogram satellite. We are launching 2 satellites next year for undisclosed customer for space domain awareness, similar type of platforms. We are developing a complete constellation of electro-optical SAR constellations. Now we are going to come, when I see here multi-sensor payload, in my opinion, multi-sensor, when you talk multi-sensor, I believe all the assets what you have on ground. For example, you have radar, you have other telescopes, you have other intelligent information on the ground. This is how you fuse with your space assets. And then you go to the command control center, and then you have full visibility of your whole theater. This is what I call a multi-sensor payload fusion and integration. And right now we are doing one program for a particular nation, and this is like a 7-year program. By 2031, we will have a central nodal theater where all forces, all assets will be integrated into one joint theater room where you can have access to everything what's going on in the whole country. So they are integrating all the gateways, all the remote sensing satellites, they are all coastal surveillance radars, they are coastal surveillance ships, the fighter aircraft, either it could be fixed wing or rotary wing or UAVs, anything, all connected, and they get all assets. We did one presentation, I had another slide which was showing with this fully integrated asset, the time you locate a what you call dark vessel, till the time you locate a dark vessel and you send your Coast Guard to there, it was 45 minutes, the whole operation. Took 45 minutes to identify, send the mission, and to locate it. So you can see, and as mentioned, Madam mentioned, that information at the right time, that's critical for any time. Keeping in view that, so what we did, we came up with a solution of edge computing and onboard processing based on artificial intelligence and machine learning. What it does, again, I had a very nice slide, sorry I can't show. When it takes an image, it does processing on board on satellite. So you don't need to wait for the ground stations to do processing or imaging. We did a demo, we did a prototype, and you can have your right way on your laptops, the JPEG image. So you don't get the EMZ and all those multi-terabit files. So you get right away the end results. And on top of it, we have a machine learning and artificial intelligence. It does analytical itself. Let's say 2 days ago, we had a picture taken and there was nothing. And after 2 days, we suddenly noticed that there is a base camp. So this will do automatic analysis and flag it to you. Hey, there was something changed. Similarly, from the Air Force, if there is an airfield anywhere, and you can see that there were some 7 runways, there were 6 aircrafts, and 2 are gone. So you know the 2 sorties are going on somewhere, and the 5 are here, or somewhere is going on. So this type of intelligence we are talking about, and the time is critical. And this is what we are working on. When we talk rapidly deployment payload, so we are demonstrating technology this year in the fall. Our mission is IM2 mission with NASA under Artemis, where we are sending the world's first OTV, orbit transfer vehicle, which will go to the lunar orbit and bring back the satellite all the way to GEO. So this way we are going to demonstrate rapidly deployable payloads so that you can have a launcher which is LEO, and can take your satellite to geo up to the lunar orbit. No problem. You don't need to wait for a geo launches or GTO launches, which are very expensive. Plus, you have to wait forever to get a geo launch. Leo launches are more frequent and easily available from all the close-up platforms. So these are the spectrum which we are talking about. I won't take long time, and I'm here if you want to have discussion and if you want to have more in-depth discussion, because this is a very vast subject and cannot be covered in 6-7 minutes. So I can talk on for a whole day if you want. But if you have more discussion, I'm happy to answer your any question. Thank you.
Now let us hear from the next panelist, Mr. Damodaran Raman.
Good afternoon, all. I could see the deep silence because I know that it's 12 o'clock, close to lunch. And so, the order of speaking, I was just wondering that there are experts from the startups which have got their specific products to talk about. So, I am from Deloitte. What I'm going to talk, right? Either I should set the context at the beginning or I should give something at the end of the conversation. I think by default it has come at the end. So let me introduce myself. My name is Damodaran Raman. I started my career as a space scientist, the first batch of cryogenic in India, and served ISRO for 14 years. Then I moved to a multinational company which worked into the microservices, cloud and whatnot into the data. And I was a CTO and then 3-4 companies. Currently I'm with Deloitte. Now why I mention my experience, because when we look into the topic of meshed intelligence, right, and we talk about multi-sensor payloads and analytical platforms, if I really look into the each and every word, it's a PhD subject, isn't it? So that's the depth. And I have opportunity to just work on space, and I also work on the data and the applications and all the aspects, right? So currently looking at the audience and this conference is concerned, first of all, what is meshed intelligence, right? So basically it's a collection of data from the various data source, digest, very, very important. It's all easy to say. When you get the data from the different ones and then making the data consolidation, which is making a meaningful insight out of that, is not that easy. Currently, you have a lot of AI ML models which has come in, which has curated the data into the different data sets, and you have the algorithm to do that, right? Currently, when we started in 91, 92 time frame, these technologies were very, very primitive, and it will be very difficult. It's a lot of manual, laborious tasks. I think today the technology is advanced so that we can get the insights from there. And you could see the data lake, data mart, data warehouse, which you would have talked about, right? Irrespective of defense or the commercial, the source of data from the different sources, which you could able to put into a platform and how to get the relevant insights out of that. The insight has now matured to the actionable. So as a Deloitte, I think we have started our space sector a year ago, and pretty much we are trying to help the community with what is the today's the need in this particular sector. So we also published a couple of thought leadership paper, particularly predominantly on the downstream data, because that's when we see that large potential for the startups and things like that, along with the NASCOM, ISPA and CII. So when we talk about why the meshed intelligence is important at this point in time, is basically space is concerned enhanced Earth observation, because when you have the data from the different sources, I think the quality of the data which you get on the Earth observation will be more clear, and you can make the decision making faster. When you talk about the defense, it's basically a situational awareness, right? Basically, I think the more the data, precise data, and data is processed in the right way, you will also get early warning threats, improved targeting, all those aspects. So that's an advantage. More or less, if you ask, the meshed intelligence is the need of the hour today, right? Because if you are not gearing up, I think the competitor will, really surpass us. So when as a tech guy, I could see that what are the key technology enablers towards this, right? Today you see that advanced payload technologies which all our panelists which they talked about, everybody is working on the very niche area about RF sensors, right? Somebody is talked about up to how to make optical and SOR together in the same platform. I think it's going in good pace. So that's also enabling a meshed intelligence to the next level. And second is data fusion and integration, which we talked about in the length, because currently the opportunity is very good. Earlier time, the biggest issue was the storage of the data. These are all the high volume data. Thanks to cloud, which has come in, and the cloud services. When we talk about now, you have an edge location, you can get the data in any time, in any moment, right? So similar way, so the data integration and the data fusion is going to be the key. I think the lot of work has been done. I think we have also got good maturity into that area. The third one is about AI and ML. Basically, these are all the key technical enablers which I'm talking about. Artificial intelligence to the machine learning, now machine learning to the now LLMs, large language model, and then getting into the quantum now. So that's the path which is going in. You have lot of models, but your pattern recognition, your lot more use cases which you can do, which is readily available. And most of these things are open source. If you have the right data set, I think you can get the insight out of that. Edge AI applications, which panelists have talked about, it's going to be very crucial because the just in time, the time you are getting from a signal from X distance to Y and get into the ground station and then process it and then getting into, I think we don't have the luxury of that much time, right? So the design of those onboard computers in design in such a way that can we process the end-to-end in the onboard and get the end results. I think that's what it is, the new things are getting into. Communication technologies also, today if you see the satellites, because high throughput communications, right? Because satellites assets has to communicate between each other and then it also into the ground station. So that's also enabling meshed intelligence to the next level. Multi-payload spacecraft, I think panelists have talked about. I think now any spacecraft is to take multiple payloads, which will really enable us to get the different aspects of the data in the ground for the processing. When we talk about the data, everything, cybersecurity is going to be the key one, right? Particularly when we talk about, I think, cybersecurity solutions in any data transfer. I think that's an evolving process. I think it is a continuous process. That's an area. I think that there are a lot of focus which is happening across the globe, and that's going to be a very, very critical one. And quantum key distributions. Basically, I think as you know that in the software industry, when we want to, when you make an HTTPS, a URL, I think the security perspective, I think we have a proxy server, we create the JWT token and all those things, right? So those things are becoming vulnerable right now, right? So that's when I think even those securities, can we use the quantum key so that your security becomes very, very stringent, right? So that's what. Satellites miniaturization and unmanned, vehicles. See, miniaturization of satellites, I think as my friends talked about, I think the CubeSats, microsats are really emerging. And as somebody was mentioning about in the LEO orbit and then using the drone and all those things, I think the capability of getting the observatory data is becoming huge. Hence, the meshed intelligence is becoming very critical. And finally, the IoT and sensor networks, right? Pretty much, I think we need to really look into these data, which can be IoT enabled so that it reaches the destination then and there. So these are all the few 7 to 8 key technology advancement which is happening, which will really make the meshed intelligence to the next level. Quickly, I'll take a minute and close my things. So what are the key drivers? You can ask the question, why we need to go for so much of technology, so many, around 10 parameters which I talked about, because this is the need of the hour for us to do that. The reason being, so geopolitical tensions are becoming, day by day it's increasing. I think the technology is going up now, the space is the fourth fourth warfare. That's what they talk about, right? In future, everything is all to be in the data, right? So one has to be upfront in this game to be ahead of the geopolitical tensions. Second thing, modernization drive. I think particularly even in India, I think all our armed forces, defense and civilian, everything, I think we want to get into the modernization, from the legacy to modernization. See, that's also a driver for us to think of all these directions to get into the meshed intelligence. And technological advancement we talked about, I think we are into the good era of achieving all those things. And Atmanirbhar Bharat initiative, right? At the end of the day, as Prime Minister talked about, I think self-reliant. And we as a Deloitte is also working few of these things to, how to take this journey to the next. Still, we are not there. I think even when we talk about all these things, I think particularly if you talk about the satellite, 55% of the components, still we are depending on the outside nations, right? So how we can become the self-reliant? When we talk about the security perspective, this becomes the very crucial part if you don't have those component per se. So with that, I could see that the meshed intelligence is going to be the need of the hour, and it's not a choice now. And then all the peripheral factors are well in place, and we should enable our working area to get the best out of that. Basically, the reusability and resilience and time to get the information. Thank you so much.
Thank you. It was very interesting and insightful discussions we had, and I would say that all panelists could effectively showcase the industry's potential and the vital role of private sector in boosting India's defense space capabilities. So I think we can quickly go to a few questions before the session from audience, if anybody is having.
Can I give a hair down? General Brare on the first row.
Okay.
This is more of a comment and a suggestion, because in everything which you do for intelligence, it has to finally result into an operational action. So therefore, the start point has to be the user or the people in uniform. They have to give you the concept and the framework. Because as far as defense is concerned, three things are not clear, whether in peace or definitely in war. What you are looking for will never be clear. Where you have to look for will also not be clear. And what you are looking for and the time will also not be clear. So, everything is so dynamic. So, this thing which you may have the best of the intelligence, best of the sensors, best of the satellites, this whole thing has to be actually meshed. And it is not intelligence, because, intelligence is when all the information is collated at a place. Intelligence would be, let's say the X country is about to launch a war. That is intelligence. So what will come from you would be information. So I was happy to hear Mr. Chauhan. The framework on which he's working would be something, it has to be beginning to end. But then, notwithstanding all the companies which are making something, they have to fit into the mosaic. So this mosaic has to be linked in to a concept, and that concept has to be driven by the user. So, in fact, I am saying myself, that unless the user is involved, the companies will not know where to go.
Yeah, you're right. Yeah.
So, sir, absolutely right. Just to give you an idea how it has worked in our part of the world, like for the SDA, for example, or the US Air Force. So normally they are the one driven, like I said, user driven, number one. Number two, right now the SDA, they are coming up with the universal policy. That means all the interfaces from the radar or the sensors, they will be universal, so that they can be part of the big mosaic. You can just plug like a Lego. So that's what they're working on, bringing all the things into one piece, into one comprehensive Lego piece, where you can take any piece, just plug it in, and then the whole mesh will work. This is already a concept. There's about 80 to 90% the specification and the requirements are set by, as you said rightly, by the user.
User has to work on it.
Exactly. So they are the one who define, hey, this is what I want. So make sure you have the equipment which meets all the specifications and plug into play into each complete mosaic. So this is what's already happening, and this is what we are doing right now. So that is possible by 2031 only, that's what I said. This is a long roadway to go. But the concept is same, what you just mentioned.
Tomorrow we have a session dedicated to mosaic warfare. Meshed intelligence is, of course, getting all the inputs together on a platform. And the process of decision making has to be pre-fed. And on larger platforms, it becomes impossible, as General Brad was saying, what to do, where to do, how much to do, with what to do. But once you make a kill web, that we are going to talk about this concept tomorrow, I think largely the industry will understand how this entire mosaic can get activated through automated decision. So I think it's very interesting that we're already building a foundation for that.
The only thing which I don't feel comfortable, to be honest, is the automatic decision making. We are not there yet. We can dream about it, we can talk about it, we can debate about it, but we are not there yet. It's a far-fetched dream to have an automatic decision making. We can make a logic, we can have algorithms, we can do any analysis, and we can ask a recommendation that yes, this is the recommendation from platform. But end of the day, our human mind or the people who are making the decision, they should be the one making the decision end of the day.
I'm glad you raised this. That is exactly what we're going to be talking about tomorrow, that how is it going to be possible to put decision making into the process. Otherwise, network centricity and system of systems are taking you much away from possibility. But making a kill web will bring you nearer this possibility. And we're going to talk about it tomorrow.
Good afternoon, I am Commodore Sherikal. I'll buttress whatever General Pannu and General Bragg have brought out. Integration is indeed a very weak area in every sphere of life. I am very happy to hear that you are doing something, you are taking baby steps, and it should fructify in future. And you would have done a big job insofar as integration and fusion is concerned. I just wanted to ask one question. Are your systems catering for hardening also against cyber threats? Because that is also very important. And one more observation I had, somebody in the panel said whole of nation approach is required. That is an understatement. It is not only whole of nation, it is whole of nation plus friendly foreign countries also. Because space diplomacy is very important. International cooperation is very important because space is a global domain. Thank you.
So I will answer 1 and 2. Number 1, the hardening. I think with respect to the hardening, there are a couple of things which you have to keep in mind. As I think it was mentioned by my colleague as well about the cyber security. And then we have other thing, we have EMTs. Not only just the cyber security, but you have to take into consideration radiation and nuclear fusions, and now there is missiles in space. Not disclosed, but we all know it's there. And then you have another threats. So that's why it becomes important. You have multiple platforms. One, for example, what we call space domain awareness. You should be aware of all the people who are in the space in your neighborhood. What is their composition? What type of satellite they have? What is their capability? Like if you look at the satellite, we can tell easily like what type of composition it has, what type of antennas it has, what's inside it. We can do that analysis very easily based on the tools what we have today. That's number 1. Number 2, you can also introduce. Right now we are working with two programs. One we call as a QKD. With 26, I think there is a launch of satellite, first satellite, official first satellite, built by Honeywell, and we are part of that. So that's a QKD demonstration, and we are doing some nuclear watch, this and that to do that algorithm. And then we have one we call rehop transponders. And that's the trick. It's just a lower level than QKD, but it serves a purpose that your satellite becomes a fully encrypted, that nobody can come nearby to get the information what you're seeking or doing it. Right now, as far as I know, officially, there are only 3 countries in the world they have this capability, the rehop transponder systems.
Thank you.
And the second question you asked about the internationalization. So absolutely right. So the program we are working is a part of the I5. 5 Eyes what you call. So 5 Eyes are all part of this. So once you implement, So all 5 eyes can look into this one.
Thank you.
Ma'am, good afternoon. Ma'am, one question. This side. Adul Bansal from IIT Madras.
May
May
I
I?
request to reserve for during the networking lunch because I heard
Ma'am, I
from the
think-
organizers that we should wind up now. And we anyway so many are having questions. So can we reserve it or okay quickly we'll take
Yeah,
one
quickly,
more-
ma'am.
one more question. Yeah.
Probably it'll give food for thought during the networking lunch. So ma'am, quickly taking you back to the mid-80s when the Cold War was at its peak, if you recollect, the President Reagan had come up with this strategic defense initiative, that is Star Wars program. So my question is to General Pannu and the startups here. At that time, so much of research had gone in, billions of dollars had been pumped in by the USA and by the USSR as well. That time it was still intact. Are we making use of the lessons learned then? Is that research come in handy? Or it's just gone waste and we are reinventing the wheel? Just a quick question. Thank you.
We can spend hours and hours on this one. That's our offline discussion on this particular topic. Because there's a lot of money spent, and at the same time, somebody, yes, they set up the stage what we are today. It's not like we came out of nowhere. The money which was set aside at that time for R&D purposes or whatever the initiative they took, that's what we are seeing the result today. And you can see the result, like the baseline is still the same. If you look at the core baseline, it's still the same.
I'm eager to know how about the funding for some long-term R&D like quantum and all, how whether startup companies are like the funding process, is there any
Yes
problem in
and no.
that?
Yes and no.
respect?
Yes and no. Something like a QKD type, yes. These are initiatives of the government or state agencies, they do funding. And there are some programs where you take initiative looking into view of your business model. Yes, this is the future, this is we need to invest. And so we like to invest in that particular area. So then we set aside 2.65% of our budget to R&D. So this is how it works.
Okay. So I think it is time to conclude now. We had a very interesting discussion and we were talking about upstream and downstream capabilities of the potential of industry and capabilities. And I think geospatial technology, as we are all, not only geospatial, entire this meshed intelligence is fast growing and we are now talking about the spatial knowledge, instead of spatial knowledge, infrastructure. This is what we were talking since quite some time, and whereas now we are talking about the knowledge infrastructure. So data has to be converted into knowledge and knowledge has to go to the actionable intelligence. That is the need of the day. So I think let us conclude this discussion with the thought-provoking question, whether are we ready, are we equipped to take up this challenge today? Thank you very much. Thank you for listening. And we will continue the discussion during the lunch break. Thank you.
Thank you to the esteemed moderator and thanks to the esteemed panelists. Thank you for making a very animated and lively discussion. With that, ladies and gentlemen, we conclude this session, which was the panel discussion, Meshed Intelligence, Multi-Sensor Payloads and Analytical Platforms. We are now going to take a break for lunch, but please do note the timing. We are going to start the next session sharp at 13:55 hours, so please do make sure that you're seated well in time. Thank you and enjoy the break.
How are you?
Thank you.
Good to see you.
Yeah, you too.
Yeah. We'll be again in the panel.
On Friday. Yeah.
We'll jam it.
Hey?
I said put two in Commodores there.
Yeah. So again, it'll be a compressed, but yeah, okay.
It's okay. Whatever time we get.
Hey, it's 1 hour.
More aim of mine is to listen.
Yeah.
Or whatever you talk, then you're not listening.
Yeah.
Good is to listen. So I don't mind cutting short my talk to just minutes, to 7 minutes, to 5 minutes. It's good to listen or just give time more.
There's lots of fighter pilots here. Lots of people. So I'm going to talk about Boyd's OODA loop. You know OODA
Yeah,
loop?
OODA loop, yeah.
Yeah, OODA loop. I'll talk about that.
That's it.
And
That's it.
how that works in space tracking. You know,
That's it. OODA loop in space, I think, is one very important.
how you get decision superiority over your adversary.
That's what will be interesting to see. You know, when I was doing one of the higher courses, higher command course we have. So this was my topic of dissertation, my MPhil, when you do MPhil degree. You have to do a research thesis. So this was my topic of my thesis.
Right.
OODA loop, and in my case, OODA loop was for nuclear conflagration. See, why? Because India, we follow no first strike.
Yeah.
Pakistan is known to be saying, I don't know whether they'll do it or not, but they propagate that they'll be first choose. China is halfway.
Right.
They say we can be first choose against a nuclear state, and second, NFU basically against a non-nuclear state. So if I calculate, it comes that China is also first strike against us because we are nuclear state. Irrespective of the size of the nuclear arsenal, China. So India is now sandwiched from both sides with two nuclear states, both directly or indirectly propagating first choice. And we say non-NF.
And China
So my entire thesis on this, whether this will function or not function.
Yeah.
What are the pros and cons of this? How India will come out if there is a nuclear exchange? It has to take place.
Yeah.
What kind of triggers are there? And what kind of decision matrix we have? Within our decision matrix, that OODA loop that we have, will our politicians, because the firing button is with the Prime Minister. It's not with the military authority. So
that's a big problem.
That's it. So that OODA loop gets huge elongated.
Yeah.
Because they will not do that. So will there be force? What kind of thing? What kind of entertaining you have to have with politicians? This was my topic of thesis, my thesis. And by the way, I won the gold medal.
Sorry,
I won the gold medal in the course.
Oh,
but that is okay. I had brought in a lot of issues, which is very much point. This OODA loop which you're talking about, what decision making in space, what decision? I think I'll read about
No, it's a Canadian company. Canadian UK company. But we are